Alright, and we are back. I'm gonna give it a minute. I know we're early. Yeah, I'll just wait a second before we get back into it. Wait for some people to gather, and then I'll put up the starting now slide. Uh, don't forget after this to go get your test. If you're watching this live, if you're watching this at a later date, uh, hopefully you got your test before 2, because that's when they go pick them up. Alright. Excuse me. Alright. Just give it just a moment longer. Okay. That's long enough. I'm going to go ahead and get started. I'll leave this up for a few seconds so people scrolling through know when to start. This might make it easier to edit if I ever edit these into something cohesive. Alright. A transformer. Everybody got that one? Is an electric device that uses electromagnetism to change voltage from one level to another. Blink is the property of a device or circuit that causes it to store energy in a magnetic field. That is inductance. We've covered inductance thoroughly in class. Uh, but inductance has to do with a magnetic field. It's storing energy in that magnetic field. Self-induction. So an inductor will induce a voltage back onto itself, and that's where most of the opposition of the current comes from an inductor. Not just the resistance of the inductor, but it's opposing itself with the induction. Mutual induction, that'd be like if you have a transformer, the different sides of the transformer are going to induce a voltage onto each other as they are working, and it's something that happens and it's unavoidable, but it's a mutual induction. Um, what is the turns ratio of a transformer? So this one's fairly simple. Let's open up another paint. There's probably an easier way to do that, but this is what we got. Where are we at? Where are we at? There we are. Alright, so, I mean, it's pretty simple. We have, what were our numbers? I know it's 31 and 62. Okay, so this question skips ahead a little bit in the discussion. A transformer has a ratio of turns. So one side of the transformer is going to have just a bunch of turns, and the other side's going to have less turns. So we would say this side has 2 turns for every 1 turn that this side has. And that would turn into, if I put 480 volts on this side, I would get 240 volts on the other side. But since the wattage, so we'll say this is 1200-ish watts. Y'all don't nitpick my math here. 480 volts, 1200 watts. It's going to be 1200 watts on the other side because transformers are based on their wattage. So for it to have the same wattage on both sides, 480 volts going a 2-to-1 ratio, your amperage is what's going to change drastically. So if we had 480 volts and 2.6 amps, on this side you're going to have 5.2 amps. And I think 480 volts and 2.6 amps, it gets as close to 1200. I'm not entirely sure, but that's what we're working with. So if it's a 2-to-1 ratio, your amperage is going to be higher on the lower ratio side because the voltage is actually what's changing, but it's having to pull more, it's generating more amperage because it's having to keep with the wattage. Back to the quiz, it's a 2-to-1 ratio. 31 to 62, it's 2-to-1, and that's the only one that's actually reasonable in the answer choices. A transformer has a secondary voltage of 12 volts and a turns ratio of 10-to-1. What is the value of the primary voltage? So what this is saying, it's 10-to-1, and the secondary, so this is primary and secondary, and the secondary is 12 volts. So you could say for every 10 volts on the primary, you have 1 volt on the secondary. So if you have 12 volts on the secondary, that means you have 10 times as many on the primary. So that'd be 120 volts is your primary. And that's the answer. I'm glad everybody went one direction with it. Like, you either move the decimal one way or move the decimal the other. I like that. The important part is that this is the secondary voltage of 12 volts. If it'd been a primary voltage of 12 volts, the other people would have been right. A blank is an extra electrical connection on a transformer coil that allows a varying number of turns of a coil to be part of the circuit. So this is the coil tap. And I looked up coil tap. Apparently there's a band named Coil Tap, but or guitar part or something. I don't know. Either way. Let's find some picture. Here's the picture I used yesterday. One would think I just saved the picture, but at least now you get some attribution. Okay, so on here, if you look right here, all these little bends in the coil where you could put the bolt through and tighten it down, that is a coil tap. So, and what that does is your current or your turns ratio, let's say it's 40,000 turns to 3,000 turns, just to make the math simple. What you can do, and this would be a ratio, and you would solve it down to 40 to 3, but this is the actual number of turns on the physical transformer. What you can do, if your voltage is slightly off and you wanted to change the voltage just a little bit, you could move the coil taps and change it to from 3000 to 3050 or 2947. And that's using different taps, and that's going to change your ratio up a little bit and let you solve voltage issues. Blank loss is power loss. This is eddy current loss. That has to do with your the frequency and magnetism and a few different things. But what happens is the higher your frequency goes, the more the current is pushed towards the outside of the wire, and that will increase the actual resistance. We mostly live in a world of 60 hertz, so we don't like what we use is what we're used to, and nothing's really different. But in the world of like varying frequencies and electronics and stuff, you can get much higher frequencies, and that will cause eddy current losses and skin effects and things to a level that's actually noteworthy. Hysteresis, we talked about that last lesson. If you're new, hysteresis it's a term in a lot of different things, but it's where whenever things change, there's a lag between the secondary value that it's gonna get there, but it lags. A good example is whenever your AC kicks on at night or during the day, probably. When your AC kicks on and your lights dim for just a second, that's your transformer catching up because the amperage shot up and then the voltage, like, it kind of went like this. The amperage shot up, and to have the same wattage, the voltage dropped down for a second, and then it came back up while the whole transformer gets to that new level of magnetism. Transformer mutual inductance is referred to as a coefficient of coupling. Yeah. That's it. It's another word for something. Yeah, there's not much more to say about that. Liquid immersed transformers are usually immersed in oil. Usually it's mineral oil, but sometimes they use specialty oils. Mineral oil is non-conductive and readily available. You go to the store and get it right now. Probably. I don't know what the supply chain has done here with current events, but you can generally go to a store and get mineral oil. Some people actually build computers in like fish tanks and fill it with mineral oil so it looks like your computer is submerged in water. They're really hard to work on because everything's covered in oil. The blank in a transformer is the difference between the hotspot maximum core temperature and the temperature when not operating. That's temporize. That has to do with whenever it's not running, sitting idle, and then the maximum temperature it could have is called the temperature rise. Bushings, you have to have bushings coming into a transformer. And then I used wattage in my earlier drawing. This actually should have been voltamps. Voltamps and watts, like we've learned in AC theory, voltamps and watts are the same value. Oh yeah, my nose is itching. So bad. Alright. Wow, we got right at the end. Okay. We are back to this, and I'm gonna call this good. Let's see, let me give it just a moment. I think everybody's done though. Got 21 to 22 out of 14. Yeah. So we're gonna finish. It's right at 11. I'm gonna start the next quiz right now. I will see you guys at. Come on, load up. I will see you guys at 1:45. Remember, go pick up your tests before 2. You have between 11:30 and 2 is when you can pick up the test. If you are not going to make it, be sure to call the office before 2 to set up a time to go pick up your test. All right, let's get started. I don't know if you go inside, Ashley. I think the tests are just sitting out. I'm not actually there, so I don't know what exactly the nitpicky parts of the procedure are. I'm sure it's obvious. Nobody has had an issue yet, so it should be pretty simple. So yeah, I will talk to you guys at 1:45. If you have any questions about picking up your test, go ahead and call the office, and they can get you set up. All right. Oh wait, don't end the current activity. End the stream. All right. See you guys at 1:45.